Hey everybody. Today we're going to take a look at polynomials. We'll start with some vocabulary, then we'll move into adding and subtracting. In the coming days, we're going to be doing lots and lots of stuff with polynomials. So we'll start with vocabulary. We're going to add them, subtract them, multiply them, and just do some different things with them. And then we'll get into some other kind of numbers that we haven't studied before. So that is what's coming up in the Math 2 world. So let's get started. I am going to go through and give us some examples and names for our degree, which is the same as the exponent, same name as the exponent. And then we're going to go through and classify things by the number of terms. So you may have or probably should have seen some of these, if not all of these, in Math 1, but they may have been a very, very long time ago, which is fine. So we'll get you all caught up today. So degree is another word for exponent. So I'm going to try to write that off to the side. Exponent. So your highest exponent is 0, it has a name. If your highest exponent is 1, it has a name, etc., and so on. So degree is your highest exponent in the problem. So if your highest exponent is 0, it's a constant. A constant is just a number. There are infinitely many examples for just the numbers. I'm just going to pick 7. Okay. If you want to pick 10, great. 1,000, great. Even 1/2, great. So constants are just numbers. If your highest exponent is 1, that is linear. An example of something that's linear would be 7x to the first power. If your highest exponent is 2, that is a quadratic. And the name or an example for that would be 7x squared. That would be something that is quadratic. If your highest exponent is 3, that is a cubic function. An example, 7x to the third. If your highest exponent is 4, that's quartic. And you probably guessed it. I'm just going to keep it pretty basic just because right now we're focusing on the degree, which is your exponent. And the last but not least, if your highest exponent is 5, that is a quintic term or polynomial. And that is the number 5. So if it's just a number without a variable, that's a constant. First power is linear. Second, quadratic. Third, cubic. Fourth, quartic, and 5 is quintic. So these are the names of our terms classified by the degree, which is the highest exponent. Now, there's a whole nother different classification that I can also classify polynomials. So we can classify by the degree, and we can also classify by the number of terms. So I'm going to go through and I'll give you the names and then we'll make up an example. So if there's only one term in the polynomial, that's called a monomial. And an example would be 5x squared. Now, it doesn't matter what the exponent is as long as there's only one term. I could have done 7x to the third. I could have done negative 3x to the 10th power. So as long as there's only one thing. So the prefix mono is 1. If there's 2 terms, this is a binomial. So the prefix helps you out. Bi, that means 2. So an example would be 5x minus 10. So there are infinitely many examples. I'm just making up one as I go. So this has 2 terms. 1, 2. Next, what if there's 3 terms? Then that would be a trinomial. An example, I can do 5x to the 4th plus 3x squared minus 2x. So it has 1, 2, 3 terms. Terms are separated by plus or minus sign. So 1, 2, 3. And if there's more than 3 terms, we just call it a polynomial. Poly means many. And so an example would be 5x to the third minus 2x squared plus x minus 11. So 3 or more, actually more than 3 terms. So 4 or more terms. So this one has 1, 2, 3, 4. So there's two different classifications. We can classify by the degree, which would be words like constant, linear, quadratic, cubic, quartic, quintic, or we can classify by the number of terms: monomial, binomial, trinomial, and polynomial. So there are some different ways that we can do that. All right. I have some polynomials down here. We're going to go through, we're going to write them in standard form. Standard form is going from the biggest exponent and then working your way down. We're going to classify it by the degree, and we're going to classify it by the number of terms. Now, the first one's already done for us. Let me just kind of talk through it. So it's not in order. You want it to go from the biggest exponent, which is x squared, then the next one, which is regular x, and then my number. So I've already written that in here. So negative 5x squared plus 7x plus 6. We have to put it in standard form. Biggest exponent and work your way all the way down. Now we're going to classify it by the highest degree. So 2 is my biggest exponent in the problem. And the word associated with the degree of 2 is quadratic. And then last, we just count the number of terms. 1, 2, 3. So it is a trinomial. All right, let's try the rest of them. So I want to put it in order. This one is not in order. It needs to go x to the 5th, then x squared, then x, and then your constant should be last. So if I rewrite that, that would be 3x to the 5th plus 3x squared minus 9x minus 7. Now it is in standard form. My highest exponent is the number 5, so you can look up at your chart there. The number associated with 5 is quintic. And if I classify by the number of terms, we just count 1, 2, 3, 4. It's got 4 terms. It is a polynomial. So make sure you keep your terms and stuff out. Hopefully you wrote those down in your notes so that you can classify. All right, so I just zoomed out there so you can see I'm getting the words from our notes from up above. All right, next example, 17 minus 9x to the third. That is not in order. It should be negative 9x to the third plus 17. So it's got to go from the biggest exponent and then work its way down. The highest exponent is 3, so the word associated with that is cubic. And how many terms do we have? 1, 2. That word is binomial. And last but not least, I need to rearrange this. It's not in standard form. I need to go from the biggest exponent and work my way all the way down. Highest exponent is 5, so we've seen that word already. That word is quintic. And how many terms do we have? 1, 2, 3. So it is a trinomial. So these vocabulary words are very important because the problem might say something like, state the coefficient of the linear term. So coefficient is the number, the big number in front of a variable, and linear, that means you would be needing to look for something that was x to the first power or a variable to the first power. So we got to make sure we know our vocabulary words as we begin to answer questions. Now, I want to end this video by adding and subtracting polynomials. We're going to add like terms and subtract like terms. Like terms have the same variable raised to the same exponent. Like terms, same variable, and that variable has to be raised to the same exponent. All right, adding polynomials. So, like terms, 4x with 9x. And I'm going to do a little squiggle for my constants, 5 and 16. So as you go through these, if you need to circle things that go together, highlight, put triangles, just make sure you know like terms have the same variable raised to the same exponent. So 4x plus 9x is 13x. And 5 plus 16 is 21. Okay. Next, again, like terms. 8x squared plus 2x squared is 10x squared. I'm going to do a little squiggle for my linear terms. Okay. 9x plus x is 10x. And negative 10 plus negative 1 is negative 11. So I put the constant terms together. Okay, again, you don't have to, but we're all at different levels with math. So if you need to circle things that go together, underline, highlight, feel free to do what you need to so that you know what like terms are. And we are adding these together. Last one, like terms. If I'm looking here, I don't see anything that goes with this a to the third power, and that's okay. So nothing goes with that. You want to write your answer from the biggest exponent to the smallest. So this 7a to the third, nothing went with that. So I just brought it on down. Okay. I got some like terms here. Okay. 4a squared plus 9a squared gives me 13a squared. And I got some constant terms that go together. Constants are just the number. 10 plus negative 8 is 2. So this is our final answer. So like terms, like terms, like terms. Same variable, same exponent. You add those together. Do not change the exponent. You're only changing the coefficient. And the last thing that we're going to do today is subtract polynomials. When you're subtracting polynomials, I encourage you to keep, change, change. Only when you are subtracting do I want you to keep, change, change. So we're going to keep the first polynomial. Do not change anything about it. Keep it just like it is. Change the sign to addition and then change the other polynomial. So keep, change, change. This is because a lot of students mess up on their signs, like positives and negatives. You forget to distribute. You forget a negative is a positive. So if you keep, change, change, it'll make your problem a little easier to manage, which is what we're all about, right? So let's go through and do some subtracting examples. We're going to subtract 5x plus 16 minus 2x plus 8. We're going to keep the first polynomial, change the sign, and then change the sign of everything else in here. So this is going to be negative 2x minus 8. So what I did is I kept the first polynomial, change from subtraction to addition, and change the sign of everything inside the parentheses. We keep, change, change. Now it turns into an addition problem. So you should have 3x plus 8. So our final answer should be 3x plus 8. So we keep, change, change. Keep the first polynomial, change subtraction to addition, and change the sign of everything in the second polynomial. That way it turns into an addition problem, which most people are much, much better at than the subtraction problems. All right, let's try the next one. We're going to keep it, change it, change it. Keep, change, change. Keep the first one, change the sign, change the signs of everything. Like terms, that's going to give me negative 16p squared. I only got one p term. I only have one linear term, so that's going to come straight down. Nothing goes with it. Bring it straight down. But I do have some constants that go together. Negative 1 and 20 is going to give me plus 19. So I did keep, change, change. And we'll take a look at one more subtraction problem. Keep, change, change. Keep the first one, so I'm just going to rewrite it. V to the third plus 6b squared minus b. Change the subtraction to plus, and change the sign of everything inside of here. So keep it, change it, change it. Keep, change, change. All right, I see I'm going to start with my cubic terms. That's going to give me negative 3v to the third. I'm going to do my quadratic terms. That's going to give me 8v squared. And then I'm going to do the linear terms, and that's going to give me negative 4v. So only with subtraction do you keep, change, change. Okay, so the v to the thirds went together, the v squares went together, and then the regular linear terms went together. So we keep, change, change.